All right, Falcon fans, we are going to be working on worksheet 4.1b, concentrating on triangle sides and angles. These first questions ask us to graph the triangle and then use the distance formula right here below to classify the triangle by its sides. Remember that if it is a scaling triangle, it has 0 sides that are the same. If it's isosceles, it has 2 sides that are the same. And if it's equilateral, it will have 3 sides that are the same. The first question that we're going to do, number 1 right here. Oops, sorry. Question number 1 right here is graphing. So we're going to graph these 3 points on this graph below, and then we're going to calculate the length of the sides. I want you to pause the video. I'm going to graph those, and let's compare what we have. All right, take a peek at the triangle that you have. Does it look like mine? Did you label the 3 corners, A, B, C? Did you connect them all? The next thing we're going to do is we are going to calculate the length of each of the sides. Start here on the left with AB, counting the spaces, 1, 2, 3, 4. If you go straight up and down, you can just count the spaces. From B to C, 1, 2, 3, 4, 5. 5 spaces. And then to do from A to C, we are going to draw our triangle and use the distance formula stated above. So to do that, we're going to connect our dotted line here and here. The distance between those points is 4, just like on the left, 5, just like on the bottom. 5 is our x distance right here, x minus x. So our distance formula is 5 squared. Our y distance right here, y minus y, is 4. So that's 4 squared right here. The formula asks us to add those two numbers together. So when I do that, 5 squared is 25. 4 squared is 16. And I get the square root of 41. No need to convert that to a decimal. The only thing we care about is that we have 3 different sides. And that makes our triangle scalene. Now let's try number 3 since I have it on the screen here. Again, I want you to pause the video. I'm going to graph it and we're going to compare what we have. All right, there's my triangle ABC. I've already calculated the bottom of the triangle. It's 4 spaces going straight across. Filled that in. Again, to calculate the distance between the the points on the slant, we can find the distance of the y's, or excuse me, the x's, which is 2, and the distance of the y's, if we count that, 1, 2, 3, 4, 5, 6, 7, 8 spaces. Remember, we can use our distance formula, which is 2 squared plus 8 squared, and square root of that. 4 plus 64 is 68. So from A to C is the square root of 68. Now if you're interested in trying to use the formula, let me point that out. If we're going to go from A to B, we would use our A and our B points from above. The formula says that we subtract the x's first. So we're going to do 1 minus -1. So I'll write here 1 minus -1. We square that. And then we do the y's, the 6 minus -2. And we square that. Then we add those together. We will take the square root. When you when you subtract a negative, it's like adding the opposite. So we end up with 2 squared, and add 2, we get 8 squared. You'll notice from above, that's exactly what we have right here. We have the square root of 68. We have 2 sides that are congruent. That makes our triangle isosceles. All right, flip to page 2. We are going to be naming these triangles. Specifically, remember we're going to be talking about equilateral, that has 3 equal sides, isosceles, 2 equal sides, scalene, 0 equal sides. If I look at question number 5, we notice that it has 4 sides that are the same. That makes it equilateral. The explain why is the important part, and all you have to do is write the definition of your triangle. A triangle with 3 equal sides, and that's why it is. When you get to the other column, you will be doing acute, which has 3 angles that are less than 90. A right, which has 1 right angle. An equilateral, which has 3 equal angles. And an obtuse, which has 1 angle more than 90 degrees. All right. The last questions we're going to work on this page are down at the bottom. We're going to be doing questions 13 and 17 together. For these questions, we will be sketching triangles that satisfy the requirements described. Be sure to include proper marks or numbers. Right, not possible if you cannot draw the triangle. So question 13, we're going to do a scalene triangle which has 0 sides the same. We're going to do a right triangle which has a 90-degree angle. So first we're going to start out with our 90-degree angle. And then scalene, 0 sides the same. Mark all 3 sides different. You have a right scalene triangle. Then question 17, we're going to do a right equilateral triangle. So again, a right triangle, thinking 90 degrees. Equilateral, we have 3 sides that are equal. First thing we think is to draw the 90 degrees. But then an equilateral triangle has 3 sides the same. The problem with that is opposite this big angle, we have to have the longest side. So it's not possible for the longest side to be the same as the other side. They must be different. And so we're going to write not possible. You cannot have a triangle that is both right and equilateral because it must have one side that is the longest and therefore not the same as the others. All right, now flip to page 3. We will be finding values of x or y as they work into the picture. Remember, we're looking for angles that are interior, the sum of which adds up to 180 degrees, or exterior, which is where we set the 2 angles equal to the outside angle. If we look at question 19, we notice all 3 of those angles are interior. So I'm going to make a note of that. That means that these 3 corners have to all add to 180 degrees. You'll notice that there is no number here in the lower left, but we understand that that must be 90 degrees. So when we set up this problem, we do 35 plus 90 plus x equals 180 degrees. All right, I went ahead and did the numbers there, solved that equation. Turns out that x equals 55 degrees. The next question, number 20, we look at that and we notice that all of the angles are outside of the circle. So we're going to mark that as exterior problem. When we say that the 2 angles equal the outside angle, we're talking about the 2 angles that are farthest away from it, remote interiors. and they always equal the exterior angle. So in this case, we will take 42 and 20 and equal it to y. Added those up real quick. It turns out that y is equal to 62 degrees. All right, the last question on page 3 that we're going to work on is number 28 here. We need to calculate these three angles using this picture right here. Some things we want to think about, what we know about vertical angles, 180 degrees in a triangle. Maybe linear pairs can come up to play. We can even use the exterior angle rule. The first thing I notice right here is that we have two vertical angles, so we know angle 2 has to equal 30 degrees. The other thing that I notice is that I have a triangle right here where I know two of the angles, 70 and 30. That adds up to 100 degrees. So we know here that angle 3 must be 80 degrees because there's 180 degrees in a triangle. And then moving over to the second triangle, we have also two angles in that triangle. This box being 90. 90 plus 30 is 120 degrees. That means angle 1 here has to be 60 degrees. I want you to go in and fill in your three angles up here. 1, 2, 3, using the diagram below. Thinking about which ones did we use vertical angles on, which ones did we use 180 degrees on. All right, again, question 30 through 33, I'm going to work on the diagram on the right. Again, we're thinking about linear pairs, vertical angles, 180 degrees, exterior angles, any of those ideas we can use. So some things I notice right here is we have a straight line. Angle 2 and 58 are a linear pair. So 180 minus 58 would be 122. Then we have a triangle on the top, 180 degrees in that triangle. We have 122, we have 22. Add that up for 144. Subtract that from 180. And we end up with 36 degrees right here. Moving to the bottom triangle, below it, we have vertical angles right here. So angle 3 has to be also 122. And then moving to the triangle at the bottom, remember that it is independent from the triangle at the top. We have the 20 and we have the 122. Add those up for 144, and it turns out this angle right here is another 36. Let's move to the next start question. All right, for question 37, we will have to find the values of x and y. Looking at this picture, we have a couple things. We notice that we have parallel lines right here, cut by this transversal. So the first thing I notice is that we have two angles right here that are corresponding angles. That means angle x has to equal 118 degrees because corresponding angles are always congruent. And so we'll fill that in. Then if we look at the triangle below it, we notice that we have the exterior angle, 118, outside of this triangle here. I know that y plus 22 has to equal 118 degrees. Take off that 22. And angle y has to be 96 degrees using the exterior angle rule. All right, the last picture, we're going to work through the answers, and you're going to fill in the blanks. We notice on this bottom triangle that we have two of the three angles, the 40 and the 20, adds up to 60. The entire triangle adds up to 180, so we subtract that, and we have 120 degrees for angle 4. Vertical to that, we have angle 2, which is another 120 degrees. Then we have linear to that,